मैं मुझे अरेंज करना था, ये तो नहीं पता।
हेलो 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 हेलो।
गुड मॉर्निंग मैम। गुड मॉर्निंग सर। ओके सर, ओके सर। गुड मॉर्निंग। इन लास्ट क्लास ठीक है ना? हेलो, ओके। हाँ लगा दिया है। So, good morning. In the last class, we were in between somewhere in machine learning techniques. So, we will go to that point, and before that, we just in 2-3 minutes we will recapitulate what were there in the last class. So, we first see how the regression line was developed across the points, data points, and equation was developed. Some coefficient was learned by the regression model, and the nonlinearity in the data set when the dimension means input parameter get increased from 2 to 3 to 5 or more, then that nonlinearity among the data set is the main problem where conventional statistics fails and machine learning comes into the picture. And then the supervised learning, that is data with outcome level, and unsupervised learning, that is data without any outcome level. So this was the summarization where the different algorithms are applied with depending upon the availability of the data and our objective, what we want to do with our data. So this was the main summary till now. Now, in the decision tree making, we have seen the decision tree has multiple nodes. From root node to the leaf node, different parameters is analyzed. Good morning, sir. So in the decision tree from root to leaf, every parameter, input parameter is analyzed for its decisiveness to classify the data set. What is decisiveness? That is identified by the term information gain. By applying any parameter at some node, for example, root node, where we should start, that is defined by the information gain by input parameter. What is information gain? Information gain is the characteristics of that parameter what will tell how good it is to classify in between two class. It is a quantitative value. No one can tell by looking at a parameter who has many number of samples. It is a long continuous variable, maybe means with values, or it may be categorical variable with different categories. So there has to be some mechanism, statistics for that. So for that, this Gini index entropy is the term in stats. It has mathematical formula. It calculates the amount of information in that input parameter. What is the information? Information is how many classes are there in this parameter, means for example, for an input parameter, there will be number of samples. So how samples are having the output level. Depending upon this output level and input value, the mapping is done, right? Whatever is the internal mechanism, it may be regression, it may be decision tree mechanism, it may be something other. But the mapping is the main idea. So what we are trying to find here, how good we can give that input variable to make that input variable in some way, some negative class, means among the two class, some sample will go to one class and the opposite class will go to the other class. Means we are dividing the root node to some to intermediate node, so that the negative and positive class will be most accurately classified. This is the idea. So for that, this Gini index entropy is a statistical formula that is calculated, and the lowest is the value, highest is the information gain. No, ma'am. The data you have given, the statistical model will calculate this Gini index entropy value. It is merely mathematical calculation. The value will be calculated. The lowest is the value that will be chosen blindly. If you are choosing to use decision tree based classification model, this is the statistics in the background, ma'am. So you can choose multiple statistical methods that will go on in the background. That is the part of data scientist job, actually. How good some statistical analysis will do this work, that is data scientist job. I'm giving you the idea what actually decision tree means when you will see a decision tree in a research article, how we will interpret it. So that topmost node is the statistically based node to first tell some sample should go to one class, some sample to go to another class for a best accuracy, having a best accuracy. And it will not end here. When it is giving some sample to different child node into side, there may be some impurity, means they are not fully classified. There may be some impurity, and at that point, depending upon the samples at this second intermediate level, the same thing will be repeated. This Gini index and this entropy, whatever the stats is, it will be calculated. The best input parameter will be chosen that can classify it in best accuracy, and that will be the second level of node where the decision tree will depend on that parameter, and it will again bifurcate the samples into next level of intermediate nodes. In this way, it is a iterative process. So when you will look into a decision tree, you should know the topmost node is the most informative best node to identify, to classify these two class, what is in your objective. And next level is the next level of important parameter, means that is the significant parameter for this classification job. So this is the interpretability of a decision tree. When you see the decision tree, how to interpret the clinical parameter who are coming out to be the best, and then next best, then next, to classify in between two groups. It is there, ma'am. If the result you think it is clinically not good at all, then it has to be reframed with some different type of statistical method, optimization method. There are different variety of things. I'm coming to this. So I put up some equation for that. Don't look into this. It will only confuse you. So we will give this example that we discussed in the last class with age group, mean BP, and the risk level of the samples. So with this input data, the age group column, if we take this column, the Gini index is red, boundary line is showing 0.28 by this formula. Don't bother about the formula. This is the idea what I am trying to convey. For each and every input, this information gain is calculated. The lower is the information gain, the better is to classify. So for age group, the value is 0.28. And if we see mean BP, the Gini index is 0. Means this is the best parameter can be to classify it. And if we do the decision tree, the root node is, it will look like this. Root node will be the best parameter to classify the samples. And some threshold value is picked up by this method, statistical method. The splitting threshold is 147 BP. And less than 147 will be one cohort, and greater than will be another cohort. And it is purely classified because at each node, the Gini index is 0. If Gini index is not 0, it may be 0 to 1 value in between. So closer to 1 value means lot of impurity is there. Impurity in the sense it is not classified properly. Lot of many classes. If it is binary, then 2 class of samples are there at this node. If it is categorical, there may be 4 or 5 grades. Then all of classes are here in this node. So more classification iteration is needed. But if it is 0, that means classification is done. No more classification is needed. Yes. Yes. So this Gini index is the main calculation here to choose up, to pick up input parameter for classification. Whatever the input parameter have minimum Gini index, that is the best to classify the sample. That is in your hand. But if the data change, then this total decision tree can change. So everything is depending upon the data that it is seeing. So this is the understanding of how you will interpret and what is root node means and what are the intermediate and leaf node means. Yes, but you can fix the root node by giving your input. That mechanism is there. So after this decision tree, this is the basic level of classification based on tree-based algorithm. It is advanced level of tree-based algorithm are available. They are random forest, XGBoost. So more and more decision tree is developed in this random forest. Forest means there are many trees. So randomly the input parameter is picked and tree are constructed, and then this voting mechanism is applied. Which parameter should be the best? What bifurcation rules is the best? So among these trees, the best is identified, and that is the final model that will be. So this is the idea. So how this feature importance will be calculated, how the bifurcation will be calculated, everything is based on that Gini index and information gain. The mechanism is same. Here, multiple trees are generated, and by the majority voting, one tree is selected. And in XGBoost, multiple trees calculated based on the previous tree's error. It is sequential process. It gets improved one by one sequentially. So XGBoost is the current tree-based algorithm. It is an ensemble model, means ensemble word you will frequently found in the papers, articles. Ensemble means combination of different process. So this is combination of different decision tree mechanism. So it is an ensemble mechanism, and it sequentially improve by learning the error from the previous tree. So here in the random forest, for example, first tree is giving a prediction model. The all samples are classified. There is some accuracy level. There is some set of root node, internal node, the whole setup. Second one is another decision tree. And remember, please remember, using random part of data, picking random number of features, means the number of samples are randomly picked and number of input parameters is also randomly picked, and that is calculated. What is giving the best result? That is calculated statistically, of course. There will be some accuracy, sensitivity, specificity, area under the curve, everything for the ROC sensitivity idea. So there will be classes, there will be classification, how many true positive, true negatives are there, everything is same here. So according to that, the best accurate tree will be selected here. So from this forest, the best tree will be our final model. So this is the random forest idea. These are different decision trees, sir. For in a decision tree, there will be multiple. Sir, for the combination of input parameter, some portion of data will be randomly picked up. It is not for single variable. Decision tree is for multiple variable. At root node, one variable will be picked. Huh. Yes. 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 So there may be, sir, values may be, exact value may be categorical, yes, no, or for continuous variable like blood, hemoglobin, there will be values. So among all the parameters, it will be taken. I'll go to the previous slide. Yes. 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 I'm telling about, sir, the internal mechanism, how the analysis goes on from the beginning. Yes. 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 So there are different, these are all different separate algorithms. Decision tree, random forest, XGBoost, all are different algorithms. When we apply on our data set, that will give different level of area under the curve for the classification. They are all different. But at the analysis mechanism, somewhere at the basic, they are similar way. Means this information gain, how the root tree and how the leaf internal tree is constructed, in that theoretical background, all have this baseline idea that I want to tell. And again and again, hmm, hmm. Yes, 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 sir.
Then you want to improve it upon and you start
Yes,
using
yes,
the
sir.
next generation.
Actually,
Will do that.
I'm coming to that point. When we do the analysis, for example, we have a data set of clinical parameters and we are trying to classify some fibrosis grading. And we can apply this decision tree algorithm, random forest, XGBoost. XGBoost is the more advanced, higher level of algorithm. That is, they also calculate decision tree at their internal mechanism, assessment mechanism. We don't know how they are doing. It is internally done. We can only see, there is mechanism to see. I'll come at the last. So the more complex algorithm we will apply, the better classification accuracy we will have. This is the baseline idea. It is not always true, but the more complex data set is there, the XGBoost gives better result. It has been in evidence in research papers. But the basic level of analysis means that decision tree making, that is the first point everyone is doing. But how they are doing and how they are improving the classification, that gets more complex when we go from this left hand side decision tree to this XGBoost. It has evolved in years. The complexity, the optimization, the error minimization, all this type of statistical internal mechanism has been improved, and we have the best result now in using the XGBoost. So in frequently in many articles, we will find XGBoost very frequently. But one thing has to be remembered, it is based on the decision tree only. And for understanding the clinical explainability, even if the paper is showing XGBoost is giving the best result, it should show the basic level of decision tree to clinical explainability, so that clinician will understand what are the parameters the model is picking up to reach to that classification with a very good accuracy. It should not be picking up something very irrelevant that is not clinically explainable. So all paper that is reporting with this tree-based mechanism, they should report a basic decision tree with the clinical parameters to understand clinically. This is the internally happening to reach to that output. Most, hmm. Ma'am, any level of complex data can be handled by XGBoost or decision tree. It is complex, the more time complexity will be more if the data is high. That can be doable, ma'am, also. Yes, all type of categorical, continuous, all type of data can be handled. Regression can be done, classification can be done. These are all different statistical methods that will be taken care in the background. So this is very strong algorithm. It can be applied in different scenario. So it is very universal and very good for complex data, even with missing data. So
Dr. Isha,
yes.
which is a better tree? A tree which can classify the data into two categories at the first node itself, or a tree with large number of branches and has multiple parameters fitting in?
It is wholly,
classifying at various
it
levels.
wholly depends upon the data itself, how the data is. If it is very easy to classify, it will be easily classified. There is no mechanism to step jump. It is statistical process. The whole step-by-step process will be actually covered. There is no magic it is only stats. So everything will be by theory, whatever these the steps, what is the algorithm. So if data is difficult to classify, the accuracy level will be less. If it is good to classify it, the area under a curve accuracy will be very high. That's all. But there is no mechanism, means magic wand, we can make some difficult data with a good accuracy classification. So the whole idea is first giving the data set for learning the internal pattern and learning the coefficients or learning the topmost parameter in the decision tree. So model learning may be in different way. There may be different type of mechanism for learning how we will go for classification. That is called induction phase. The learning algorithm can be anything. The model is developed by this, and then this model is applied on the test data set. This is the workflow of a machine learning supervised learning, where we have the outcome variable is this class, this yes, no, red colors are the outcome levels, outcome variables. All these attribute 1, attribute 2, 3 are the input variables. So now when the model is developed, we can apply on the unknown data set where we don't know the classes. Or we may know the classes, but this model will now predict the outcome levels. And then we can compare it to have our accuracy. Area under the curve, sensitivity, specificity, whatever the statistics is. So this is the workflow. And here in this learning model, we can apply many classification model that we have seen. Regression, tree-based algorithm, and other are there. So this is the whole workflow. Now, in the training itself, there is some terminology that we should understand. Internal and external validation. The both terminology may be a little bit confusing, but this internal and external validation is totally different mechanism and very important part of this learning and testing. So from top level, we should see this. This is the original data. It has many samples. The all rounds are one data sample. Green one belongs to one class. Blue one belongs to the opposite class. Two class data is here. It is shuffled, and then the training and test split is done at the beginning. It may be 70% training, 30% testing. It may be 60:40. It may be 90:10 also. So that is depending upon the person who is analyzing. Anything is valid. From this training set, because we want to learn the model with more number of samples. So all the variability, all the combination of pattern is seen by the model, so that when it will see unseen data, it can identify that existing pattern. There may be lot of variety of patterns. So larger amount is given for the training. So that is the idea, to give more number of experience. So training sample is then go for the model training. This whole red block is model training. And after model training, model building, when the final model is developed, it will go for the model evaluation, that is the external validation testing. External validation means the testing on a data set that was not involved in this training process. The testing split is set differently, exclusively. It was not into the training data. Whatever we will do with the model training, it will be only with the training split. Testing is exclusively kept separate for the model evaluation. External validation, it is called model evaluation, testing, external validation. Different terminology can be used, but the idea is testing the trained model on a separate data set that was not part of training. Okay. It is automatically. Yes. Internal validation, I will come to that set. Internal validation take place within training itself. Internal validation is during training. External validation is after completion of training. Yes. External validation is a part of sample that is kept aside. External validation is a part of sample that was not part of training. Yes, it is also, you are telling correct, ma'am. If we have two type of validation, external validation is our data set that we kept aside and you do not use in the training. External validation may be for a external hospital data set that we are using to validate our model. That is also called external validation for multicentric project. Yes. Okay. Okay. Mm, mm. Yes. Yes. No, no. No, no. The means so the idea is whatever you have in a single center or multiple center, you have to keep the some portion of data for model performance evaluation. That is called testing or external validation. That data should not be included in the training part. This is the idea. It may be you can try, means imagine the training data was from 2020 to 2004 and then testing is from 2005 and 2006. You can take it as a single data set in your position and you can split that data set for training and testing. It is separate. Training mein testing ka nahi aayega. It is totally separate data. Yes. So yes, yes. So it is external validation because it is external. It was not during model training. Yes, yes. And this split is done at the beginning. After this split, we cannot touch this test split. If you are touching this test split and we are involving this data in the training part, that is a dangerous error because this training data set will see the testing data and it will learn the unknown data set that should not see the data. So the accuracy level will be very high, absurdly very high, almost 99%, 100. So from that result, you can only identify the model is not correctly developed actually. It has seen the test data. It is called data leakage. Means data was leaked. The unknown data that should not be leaked to the model, it has been leaked. The question paper is out. That means. So this is the question paper for the model for testing. Yes, it should be on unseen data. Yes. So now what is internal validation? Internal validation is the mechanism when the model is seeing the data that is given to it, it can see some part of data and it can test its current optimization, current coefficient on some part of data. That is called internal validation. When a training data set is splitted again, for example, it is called k-fold cross validation. External validation is something different. cross validation is different idea. Cross validation means during the training, we are giving the whole training data set to the model, but internally it is splitting into different folds. Folds means if it is K fold, K is if it is 3. For example, here it is 3 fold. This yellow is 1 fold and the gray is the another 2 fold. So every time it will take this yellow part for testing at that moment and for training the gray part in that iteration. So it will be, if it is a 3-fold cross validation, the data will be partitioned into 3 parts. 3 iteration will be there. At every iteration, the internally data will be splitted for training and testing internally, and model will try to learn more optimized way to learn the coefficients or learn the root node and the leaf nodes, whatever the mechanism is. So internally, it will see some data for coefficient evaluation and take some portion of data for evaluating the current learning. I think it is, you can see, but you can imagine this, what we are doing training and testing split, the model is itself doing internally with its own learning. So every time the one split it is seeing for testing and other folds it is using for training. And each time this testing and training will be shifted. The different folds will be figure. It is clear. Okay, I am very happy. You are for the first time you are seeing this and you are understanding and I'm able to make you understand. Okay, nice, nice. There are issues for that. If the data set is very small, overfitting, underfitting, different scenarios can be there. I'll come to that point, sir. Yes.
Different combination.
Yes.
So how many times do we shuffle to actually come to a conclusion that no more cross validation is required?
There is no mechanism to find an optimal number of shuffle. How many folds? It is conventionally used 5-fold or K-fold. Means 10. No. It is the input. We give the number of folds as the input. Yes. So we see how it is giving the result. Maybe with 10-fold, with large, it is very large data. With this, if this fold is 10, the model is giving more good result. So by doing, yes, we do that only, ma'am. We keep on changing we keep on exploring the process and we see how the model is improving. So this is who are very interested for Python programming. I have kept these 2 snapshots. This is the steps, and this much coding is only required for Python training and test split. After, of course, the reading of the data set, no need to take picture because if one line Google is enough for this. So training, testing, split, then definition of the model. This is the definition line, random forest, training and the prediction and the evaluation of accuracy. So this much is the code, but this is very basics. There are a lot. You don't need to, not just to show if someone is very interested. So you only need to know some parameters that is called hyperparameter. Sometimes you see this word in the article. Hyperparameter was tuned. Hyperparameter are the model's parameter. We give input parameter. Model have hyperparameter. The name is that. So different algorithm have different type of hyperparameter. And that is tuned, means hyperparameter is the coefficients actually. Parameters that
input to the model, like what should be the
Yes,
depth,
yes,
what should be the number of this thing.
yes.
These are hyperparameter.
So this,
For the ease of understanding, it is like जब हम लोग चाय बनाते हैं तो we decided कि sugar कितनी लेनी है, चाय पत्ती कितनी लेनी है, how long we have to boil it. So this is hyperparameter. This is pre-decided. अब चाय बन जाती है, then how tasty it is, how sweet it is. These are parameter.
so yes, these are all
In that way you
ingredients.
can easily understand.
Ingredients of the algorithm, and depending upon this parameter, this model will work. So for a decision tree, the maximum depth means how many bifurcation it will go level by level, or how many estimators or how many iteration it will go. These are all input parameters for an algorithm. And how to decide which value is the perfect for the data set. That is called hyperparameter tuning. We give certain range of option for these input parameters, and we tell program itself to find the best combination of parameters where you are having the best accuracy. That is called hyperparameter tuning. Means we are giving amount of sugar in different amount of tea leaves in different amount, and water and time. Model will pick for a Darjeeling tea, it should be boiled for 5 minutes. For a coffee, it should be boiled for 5. For a Assam tea, it should be boiled for 15 minutes. So the model will learn itself how much combination of input parameter, the best combination for giving the accuracy. This is internally done by the Python algorithm to pick up the best thing. So hyperparameter is the input parameter for the models, and hyperparameter tuning is the searching for best hyperparameter to give the best result. So yes. So now come where underfitting and overfitting comes. If the data set is very small and algorithm is very simple, we are applying very simple algorithm that cannot identify the pattern, that cannot map the data to the output variables, then this simple model is giving a underfitted result. It is not fitting the data properly, means the solution is not adequate. Overfitting is the scenario where model learns too much intrinsically to the input data, so that it is fitting each and every variability and the pattern internally, so that it is not generalizable at all for the new data. So when you have a very good training result, but not a very good testing result, that is not generalizable. Model is not generalizable. That is called overfitting. It has learned the noise, every bits and pieces of the input data so strongly, so that it cannot handle new data. It is giving very poor result. And underfitting means it is not at all analyzing the data properly. It don't know what is the pattern properly because of the very simplicity or very small amount of data it can happen. Another idea I thought I should add, this slide I has added yesterday, support vector machine that we frequently see in our articles for a classification algorithm. So support vector is a different type of algorithm that is very, very different from this tree-based model. Tree-based model has this information gain, the Gini index calculation, and the tree kind of step-by-step process. From a most informative parameter to lower amount of information, it go from root to leaf. So in support vector machine, what is done? It is done the whole data set is seen together. The nonlinearity is handled by mathematical equations to make the data set to convert the data set actually from the current structure to some another structure. So it is called hyperplane. Means hyperplane is the idea in the regression for multiple parameters, we are searching in one dimension, we are searching for a fitted line. Or for a classification model, we are searching for a line that will classify both the class. Or for multi-dimensional data, 2-dimension, we are searching a plane that will be classified, that will do the classification. Okay, yes. So that is better. So here in this first example, this is the data points, blue and pink. So it is linearly separable. But if all are overlapped, the values are all so much overlapped, there is no place to draw a line to classify it. Now this one-dimensional values are converted in two-dimensional values. Means, for example, you have x equal to 5. Now you have generated x square. It is 25. So what was in the term of single x, y, z type of means 5, 3, 7 values means in one straight line it is there. Now if we do a function means a mapping, x will be now x square, y will be now y square. Means any value is now transformed from unit value to the one square value. It may be cube, it may be polynomial. Means polynomial means to the power can be increased. Means x square, x cube, x to the power 4, x to the power 5. That is called polynomial equation, where x can be multiplied with its many terms. So in that form, the whole data will be bifurcated into different hyperplane. It is called hyperplane. There, statistically, it can be classified. So whole data set at a whole is seen, it is converted in such a way it can be classified. This is the main mechanism of this two type of algorithm, and it is very good for very small amount of data set, ma'am. That you gave me a very small amount of data set. Brute force is another process to develop the hypothesis, and support vector machine also a good model for very small amount of data set. It can handle. Yes, ma'am. Yes. That is also that idea. When the scale is not seeable, interpretable, log transformation is another way to see the data, visualize and analyze. Cutoff? Cutoff a very small data set means the threshold value at okay. Sample size. It may be 50. As small as, yes, it is very small sample size, it do good. It will work on 50. There is some mechanism for upsampling. It has to give some more data set. So for the training data that I have not told, because it will get on long and long, because there are many small add-ons. These are very basic structure. It is not very this simple. There are a lot of things actually. When we have small data set before training, after the splitting of training and testing, we do upsampling. Upsampling is replicating the data in probabilistic way so that it will replicate in such a way, it will not just copied. It is in that span, means the pattern will be taken, but the combination of parameter will be different. Yes, to have more sample. So next is the unsupervised learning, discovering phenotype. When we don't know the outcome, we try to identify the pattern in the data only. We don't know what to do with the data. When there is nothing, no identified pattern, no pre-knowledge within the combination internal pattern of the data set. This is an exploration tool, actually, unsupervised learning. So this is a discovery. This is a discovery of new pattern. It may be, it can be anything actually. in finance, in business, in scientific analysis, in clinical, any type of similarity is found actually in the data set. So clustering is similarity between samples are measured by distance measurement. This is the very basic idea of unsupervised clustering. We are finding about similarity in this room. There are a lot of people. There must be some similarity. It may be depending upon the department. It may be depending upon the gender. It may be depending on the age. So there may be different type of scenario how we are measuring the similarity. So the grouping is done by measuring the similarity. Similarity is the value that is calculated by different mechanism. It may be Euclidean distance. There are other mechanism, Chebyshev distance or other formulas are there. So the values are calculated. The distance means if P and Q is two value, the difference is calculated and it is squared and then root over is taken. Means the negative term is eradicated. It may be minus value also when you are doing subtraction. So for that, this square is done and this root over is there. So this is the basic idea of similarity measurement. So for example, if we have 1 and 2 and we have mean BP and both are in age group 1, these are too similar. If we are seeing 1 and 3, age group is different and mean BP is also quite different. So intuitively we can tell these are not very similar. This intuition, what we can see and understand, that is calculated mathematically for the whole samples actually. And for this mechanism, the 3 steps are there. We first pick some random point for clusters. We are assuming there are some similarity in the data and that may be clustered in some number of clusters. Here the number of cluster is your only intuition. Okay, there may be 3 clusters or 5 clusters. So you have to give the numbers for clusters that you are thinking of having. That is your intuition, that is your experience and knowledge. And depending upon that cluster centroid, that is called centroid, means the center point of the cluster. Every data point distance of that center point is calculated and assigned to any of the cluster that is the closest. Everything is set to any of the cluster. Nothing will be left. No one will left. Then the center point will be updated. By who are assigned to that cluster, the mean will be calculated from all the samples and centroid is updated. And it will keep on changing. When no point is moving from one cluster to another cluster, the process will stop. This is different. The tree is calculating the information gain. But no sample is moving here. In the tree, what we have done at the root level, the movement is final. Again, at the second level, what we are bifurcating on an input parameter base, it is final. No one is moving from lower level of node to the root. Here, everything can change. Depending on the distance, every point can go to another centroid, another cluster through the iterative process. How the centroid is updating, how the movement is going on from the one sample is, when it is starting with cluster 1, it may go to cluster 3 at the end. But a decision tree, it is not like that. No, ma'am. When
closer like a gradient or a wider, the closer you are, the closer to the original structure. Then you have a different farther away. So that's a different cluster. So that's what I think we
yes,
do
yes.
primarily.
This is unsupervised. Here we don't have the any label attached to the data. This will tell, ma'am, any kind of pattern
give
in the
you
data
an
set.
example, like hepatitis C is discovered. There are 100 variants. So this is the primary hepatitis C virus, and these are different, variants. So how close you are, like it is genotype 1. So this is all these samples are close to geno 1. These are close to geno 2. So the distance from geno 1 of the variants will tell you, and those which fall out. Correct
Yes,
me if,
yes.
because this we used to do very regularly, clustering.
This is clustering, identifying internal characteristics. So for the same example, if we do clustering, ultimately this will be the result of 3 groups. Here age group is total 3 groups. So it is a very simple example to understand. The distance means the centroid is here intuitively taken as 3 number of clusters, and the data set will fall accordingly upon the calculation of this similarity, the Euclidean distance of the variables. So ultimately there is no risk outcome variable, you can see. So this is a pattern of lower age group with lower BP and mid age group with a BP range, and high risk patient with higher age group. This is a very simple example, but with your data set and your domain, it can identify different type of phenotype or genotype that may be associated with different disease spectrum. Yes.
Why is 155 coming in group 2 and 154 BP is coming in group 3?
Sir, in group 2, it is 2469.
Yeah. So that is okay. 154 is coming in group 3.
So 15. Sir, here is 1 to 710.
No.
Group 1 is.
I'm saying group 3, you have a BP 154, isn't it?
Group 3 is 358, sir.
Yeah.
Sir, where you are seeing?
3 is BP showing BP 154.
Okay.
This,
Sir, this is going to group 3. This is going to group 3. The sample ID is there. Yes.
the lower and the
Lower is in the group 1. So this red circle is one group,
yeah,
rhombus is another.
I know, but there is a mix here. Higher is going into other group and lower is going into.
So it is based on mainly BP. So if BP is high, it is going to some other group.
It's not happening that way, because if you see group 3, BP is 154, 167 and 165.
Yeah. So this is closer to in higher level, closer to higher. So it may not be very similar, but it is close to high.
I thought it would have been 4 going to that group, 155, 167 and 165. It should have been that.
But mathematically,
Mathematically,
it is like
it's
that.
so close.
Yes.
Okay, so what happens if age group 1 has BP of 167?
So here the continuous variable is dominating. So it is there is difference. Yes. Yes, the age group is also, distance of age group is also calculated, and distance of BP is also calculated. But just because this age group is a categorical variable here, the more dominant is here is the continuous variable. If we have the age in values, then it would have been different way.
Yeah.
Because it is stats only. That is the main problem here. Yes, it is ordinal now.
I add an 11th patient with age group 1 and BP 167.
So age group 1 and 167, it will go to group 3 because continuous variable will dominate here statistically.
Not the category.
So that is why we do normalization in the pre-processing step. It is very good question, sir. There is pre-processing step, normalization is there so that all data set will be in one scale. So this type of problem will not be there. One is in one scale, another one maybe another scale. Because if we say platelet count, it will be in 1000. If you say hemoglobin values, it will be in very decimal value, means 10, 12, 15, like that. So it is normalized fast. Time. Yes, only single size was there, ma'am. Yeah, the idea of hierarchical, this is the last slice. Hierarchical clustering is the clustering where we don't have to give the number of cluster. The model will go on iteratively clustering and bifurcating, and this is called the tree type of structure, dendrogram. Anywhere we can cut and we can have the number of classes. At lower level, if we cut here, at the lower level, we can have A, B, C, D, E, F, all classes. If we cut at the, another above level, we will have BC1 class and A class in this dendrogram where I am pointing out. So it is a more strong type of clustering algorithm that finds its own itself, how the pattern is there and how much cluster you want to pick, you can pick from here. So there is a way to make,
Pre-select the number of clusters.
yeah, there is no pre-selection of clustering, and there is mechanism to find optimal number of class. After finding this, the hierarchies means the, ma'am, it can go from top and bottom, means we are seeing whole data, we are giving two class of based on similarity. Then among the two classes, we are then again doing clustering. So it is can go from top to bottom or from bottom to top. We are seeing each one individually, we are clubbing based on similarity, and we are going by clubbing at last all the things. So this is the idea. Ma'am, it is statistically done. You cannot do on your own. How the clustering, how the combination will be done, it is mathematical only. If there is some similarity, ma'am, there will be clusters. If some similarity should be there. So there is no limit how much similarity is required. So the it model will learn itself actually. So thank you for the class. And yes, sir. Yes, ma'am. Yes, ma'am. Sure, ma'am.